Okay, so what do we mean by metals, nonmetals, and semimetals? So metals, if you look at, let's say, a penny, okay, a penny is made from copper, which is a metal. Pennies are shiny. They're not going to melt easily, so they have a high melting point. They conduct heat and electricity well, and they have a high density. Nonmetals are dull. They have much lower densities. They melt at much lower temperatures, and they definitely do not conduct heat or electricity well. Now, our semimetals, we get some metal-like appearance to them, and we get a crossover in properties between metal and a nonmetal. That's why some of those semimetals like silicon are used so heavily in electronics, because we can exploit properties of both metals and nonmetals to make them more effective at doing things that we want them to do. Okay, so when we look at our metals and nonmetals, metals are solid, metallic, malleable, ductile. Ductile means that we can pull them into wires easily. They conduct heat and electricity, high density, high melting point, and they will react mostly with nonmetals. Our nonmetals, we see them as solids or gases. They're dull, they're brittle, they're non-conductors, low density, low melting point, and they react with metals and nonmetals. Now, in this physical state, okay, there's two exceptions. Okay, because here I've got solid and solid or gas. There's two exceptions to this. One is a metal and one is a nonmetal. So mercury and bromine exist as liquids. Okay. All right, so everything else metal-wise is solid. Everything else non-metal-wise is solid or gas, with the exception of mercury and bromine, which exist as liquids. Okay. Now, some other things that are interesting with our metals and nonmetals. Okay, metals like to form cations. Cations are positive. Nonmetals like to gain electrons to form anions. Anions are negative. Okay, so in an atom, we have protons, we have neutrons, and we have electrons. Protons are positively charged. Electrons are negatively charged. So if we lose electrons, we have more positive charges than negative charges, so we have an overall positive charge. If we gain electrons, we're gaining negative charges, so now we have more negatives than positives, so we have an overall negative charge. So what we're going to learn is that elements want to lose or gain or share electrons to form what is called an octet. Okay, an octet is 8 valence electrons. And so our group 1A metals have 1 valence electron. If we want 8, is it easier for them to lose 1 electron and have a lesser energy shell full, or is it easier for them to gain 7? Well, it's easier for them to lose 1. So our metals have less valence electrons. They're going to ionize easily. Okay, we form compounds with nonmetals, but not with other metals. And then again, the conductivity and the ductility, etc. Okay, our nonmetals, okay, they have more valence electrons, so now they want to gain. Their ionization energies are high, and they will react with both metals and other nonmetals. Ionization energy refers to the energy required to remove electrons. And so since metals like to form cations, i.e. they like to get rid of electrons, they have much lower ionization energies.